Hi, today we're going to talk about using the 1031 Systems products for creating your own Halloween decorations and animatronics type props. This Halloween I had to do everything from scratch because it's the first year I've done this. I won't have to do that in the future since I'll have a system already put together. But this first year had to do everything, made some mistakes. Hopefully we'll avoid those mistakes for you. Rather than keep you in suspense, we'll go ahead and show you what the final product looked like. Then you can decide if you want to stick around for the rest of the video. Okay, here we are on Halloween, walking up the front porch. Da 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 da, everything looks nice. La la la. Since I was starting this project from scratch, I decided to go ahead and build my own box to hold all the components. The most important thing about sizing it was that it had to hold a box holding 8 outlets for controlling up to 8 separate electrical items. So I glued up the wooden frame, fitted in the outlet box, and then sized everything based on fitting the outlet box in there. I used screws to mount the outlet box into the frame. The one in the back is just to hold it up at the same size. It's not being mounted back there. Having the outlet box mounted in there gave me all the sizing that I needed, so I was able to cut top and side panels. I screwed the side panels onto the box, making it stable and rigid. Next, I assembled all the electrical components going into the box. I broke off the tab that connects the 2 hot leads to the 2 outlets. This allows me to separately control each of the 8 outlets. Of course, if you prefer, go ahead and leave the tab on as in the bottom outlet, and that will allow you to use one relay to control 2 outlets. I didn't want to do that, so I broke off the tabs as you see on the top outlet. Next, I wired up the 4 outlets outside the box, and then I'll put the whole thing in there. You can see I wired all the grounds together with the green wires. I connected all of the neutral with the white wires, and then I have individual black hot wires going to each of the 2 outlets on each of the 4 duplex outlets. I slid the entire set of outlets into the box with all the wires feeding out through the holes in the back. Screwed the outlets into the outlet box and put on the cover plate. Next, I mounted a bus bar to provide 8 hot leads going into the solid state relays, and I mounted a board containing 8 of those solid state relays to the bottom of the box and wired it all up. So you have a lead goes from the bus bar to the input on the relay, and then the output from the relay goes to the outlet. Then of course all the outlets are wired together with their neutral lines going to the white lead going out. There'll be one additional wire here, another black hot lead coming from the bus bar and going to our input power along with the green and white wires. Next, I mounted the processor controller board in the box, put together a 10 lead ribbon cable with a connector on one end, stripped the other end, and mounted it to the relay board to provide power and control both to it. That gets plugged in and we're just about ready to control it. The next step was to hook up all the servos that we're going to control. In this particular system we're only controlling 2, one 5-volt servo for the jaw of the skull,
and one 12-volt servo for opening and closing the door. For that, we're going to use this small board that's another design from 1031 Systems. This allows you to provide separate power and ground to two sets of 4 PWM outputs. And then there's a 10-pin ribbon cable that connects to the processor board to provide the control into those PWM servos. The PWM servo board, along with the audio board, were just mounted using museum putty into the bottom of the box. The ribbon cables attached from the GPIO output block on the processor card over to the inputs on the PWM card. We hooked up a 12-volt power supply to run the big 12-volt servo that operates the door, but then we just jumpered the 5 volts and ground over to the other side to power the jaw servo. Since it's pretty small, it doesn't draw a lot of power. We probably are pushing our power limits, and it would be better to use separate power, but for a lot of things, a separate 5-volt power supply, but I chose not to, and so far this seems to work. If I was going to put very much more in it, I would probably put an extra power supply in there. You'll notice also in this image that there is an extra installed outlet on the inside of the box that we can plug our power supplies into. So there's two 12-volt power supplies, one for the servo and one to power the board. The regulator on the board drops it to 5 volts, which then powers the whole rest of the system. I added some push buttons at the end of the box. These are used to reset the system and to initiate or terminate a particular animatronics playback. I wired the two switches into the control block going into the processor board, and the system's powered up and ready to go. Notice also I put a strip of thick rubbery tape over the power bus, since basically it's hot. You don't really want to touch that, so just for safety I put that extra protection on there. And please, let me emphasize, you don't want to die doing this project. That hot bus could indeed kill you, so be careful when you're doing this. Most of the voltages in here are 5 volts or 12 volts, probably not going to do anything to you, but you are running 120 volts through those outlets, and you need to be careful. Please be careful. I completed the box by adding hinges and a top that will cover everything when it's closed. I did have one key problem with this system. I was going to control LED light strings. I was going to just plug them into the outlets. Unfortunately, the solid-state relays leak. And because they leak, they slowly charge up a capacitor in the LEDs, and the LEDs come on. That drains the capacitor, and the LEDs shut off again, and they blink on a regular basis, as you'll see in this clip. I want my final display to look like this. I have two sets of LED strings, one around the floor. These are orange, and they stay on all the time, so I don't control them at all. I just leave them on. That's to keep kids from tripping over the steps and things like that when it's dark. The LED string on the top, though, I want to turn off when the effects are happening, and so I want to control that via the relays. Unfortunately, it was going to blink, so I added a pair of mechanical relays. I'm only using one of them, and I replaced the solid-state relay with this mechanical relay on the one outlet that's controlling that LED light string, or the pair of LED light strings that are around the upper part of the porch. This allows them to go off completely and stay off. I will be replacing the entire set of solid-state relays with these mechanical relays for Christmas because my Christmas decorations are all LED light strings and I don't want them blinking at the wrong times. But that was a chore for later. Of course, to trigger our animations, we're going to need motion sensors. So I bought some of these HCSR 501 infrared motion sensors off of Amazon and wired them up. We actually are just using one at the end of the porch for our animatronics for this Halloween. The 3v3 signal coming out of the motion sensor does not have enough oomph to drive the opto-isolator on our board for the trigger, even a few inches away, much less 25 feet of cable. So to boost that, I added a transistor and resistor to give us extra drive and fire the opto-isolator and fire that trigger when the motion sensor detects motion. I bundled up the transistor and resistor inside this reusable package here that has 3 lines going out to the sensor and 4 lines connected to the board. So red and black connect to power and ground, green wire goes to the anode of the opto-isolated trigger, and white goes to the cathode. And this fires off the trigger when the motion sensor goes high. Of course, I'm going to need good sound effects, so I pulled down this stereo from the rafters in my garage. Us old timers tend to have stuff like this lying around. The speakers, nice and big, give a lot of sound. Then it's a nice 60 or 80 watt per channel amplifier driving it, and worked great. I did have to buy a cable to connect the sound card from in the box to the stereo. I bought one like this because this is a pretty old stereo. It doesn't have a small phono plug input so that I can connect it directly to my various kinds of players. So I bought this, but a more modern amplifier, if you have one, will have a phono plug input as well that you can connect them with more standard cables. And that basically completes my general purpose system for controlling my animatronics. Then we can build our customized displays, add control files from Hauntomator, and build any kind of animatronics we like.